Okay, this is problem 2. We are given information on the distribution for egg production. We know that our mean is for each egg produced is 55 grams, standard deviation 7. And we're told about their classification as small, medium, large, SML, or extra large. We have the classification by weight for each of the sections. Sketch a diagram of the distribution, and we want to check the boundaries for the classifications of eggs. So I have my normal distribution. Here's my bell curve. My mean is 55 grams. My standard deviations are 7, so this is 62, and this is 48. Now my this is weight. Now my classifications. I know it's small if it's less than 53. 53 is somewhere around here. My medium eggs are between 53 and 63. My large eggs are between 63 and 73. Oh, let me put up the bars. So this is 53. This is 63. My 73. These are large, 73. And then I have my extra large, anything above. Find the probability that an egg chosen at random is medium. Medium really means that it's between 53 and 63. To figure out that, for my medium section, and I'm going to show the work using a bell curve. I want to find the left area from 53, which I can do on Google Sheets. I'm going to find the left area from 63, and once I subtract them, I subtract this cross-hatched section, I only get the middle section. So I'm going to set that up right now. Equals norm dist. My x value is 53, that's for the green part. My mean, we said, is 55, standard deviation is 7, and true. That's the probability of being small. Medium, I'm just going to copy paste. Since I don't have any cells referenced, all I need to do is just change the value, 63. Now, do I have this right? 53 and 7? Yes, I do. 55 and 7, sorry, for my mean and standard deviation. I have this one here and this one here. Now all I need to do is find the difference. A large probability minus a smaller one gives me a probability of 485.9. Rounded to 3 sig figs, I have 486, 0.486. Probability of medium is 0.486. Now, probability of being extra large. Probability of being extra large is a slightly different setup. I don't need to make I do not need to subtract two probabilities for an interval, but I do need to make a subtraction. Extra large is anything above 73. What I can calculate is anything below 73, and then figure out how much I need to get to 1. So I'm going to get this one, copy, paste. I'm just going to do it down here. I want up to 73, the probability up to 73. That gives me a essentially a 99% chance of being less than or equal to 73. So I subtract it from 1. That gives me a 0.00506%, well, not percent, 0.000506 probability of being an extra large. So extra large is 0.00506. The probability of, so there's a probability of 30% that a randomly chosen egg weighs more than W. Find W. Again, a diagram is very useful. This probability is 0.3, meaning that the left probability is 0.7 as of W. I find W using my normal inverse function. I'll do it down here, equals norm inv, my probability, which is the x value in this case, 0.7, my mean is 55, standard deviation is 7. Now this is not a probability, this is a weight, 58.67, 3 sig figs is 58.7 grams, W equals 58.7 grams. Again, here you're specified, W represents a weight. Now, we're given the probability of getting a large egg. That's 0.121. We know that there are 2,000 eggs each month. The way to calculate how many, the number of expected eggs that will be that would be large, is the percentage of eggs that are large multiplied times the total production of eggs. So I would expect 2,000 times 0.121. 2,000 times that number should be the number of eggs. So I'm going to do 2,000 equals 2,000 times 0.121, which is given. I should expect 242 large eggs, exactly. 242 large eggs. Expected value, not that I will always get 242. Next problem is telling us, it's giving us information on the selling price for each category of eggs. Small eggs are much cheaper than the other eggs, and the price increases as the size increases. We are given the probability of getting a small egg, 0.388. Estimate the monthly income in US dollars earned by selling 2,000 eggs. Give your answer correct to 2 decimal places. Let's break this part down. We know how many large eggs we expect to produce. I expect to produce 242 large eggs. If I multiply that times the selling price, that tells me the income for only the large eggs. If I can estimate the number of eggs I have in each other category and multiply that times the price, I have a total estimate for the income for that month. I'm going to do all of this in Google Sheets because it's just that much easier to set it up on a spreadsheet. First of all, my categories are small, medium, large. I'm going to make a table over here. Here, I don't want to lose everything. So my categories are small, medium, large, extra large. Here I'm going to write down my probability. Probability of getting a small egg is given, which is 0.388. I could calculate it, but I'm just given it already, so 0.388. Probability of getting a medium egg, I have it here. It's the 486, which is still written down here. This was my probability of a medium egg, so I'm going to use all those decimals equal here. Probability of getting a large egg is, well, I have the probability of a large egg down here. It's 0.121, so 0.121. And an extra large egg, I have it here. It's this calculation I had from earlier. And I'm going to, this appears as a 0 here, however it is registered as a value. It's formatted to round. If I select them all and use one of these 2 buttons, this decreases the decimals, this increases. I don't care how many decimals show up here. It will always take into account all the registered decimals, not the ones that it shows. Now, probability. Now, I want to find my expected production. My expected production is going to be this value times 2,000. Sorry, 2,000, not 200. So the probability of getting a small egg times 2,000. Same deal here, probability times 2,000. I could actually just drag this formula down, and it will always multiply times the 2,000. Let's double check. Okay, the correct probability, and let's do this one as well. Correct probability times 2,000. That's my expected production. Now here I'm going to put my income. Income per egg. My income per egg. For small eggs, I get 30 cents. 0.3. For medium eggs, I get 50 cents, 0.5. For large eggs, 65, 0.65. And for extra large eggs, 0.80 cents. That's my income per egg. Income per category. My income per category is going to be equal to the income per eggs times how many I produce from that category. And I can drag this formula down. Again, all I did here is, if I expect to produce 242 large eggs, and I earn 65 cents per egg, I multiply them and get this value. And my total income is going to be equal to the sum of all of these values. A total of 884.10. Now, whenever we work with money, instead of rounding off to 3 sig figs, it's customary to round off to 2 decimal places representing the cents. Not only that, in this problem we're specified. Give your answer correct to 2 decimal places. So our answer is 884.10. 884.10.